Welcome to the continuing lecture on network theorems, in that Norton's and Thevenin's theorem. This is an example 3. Here the circuit is as shown here. We have got one dependent voltage source 10I, current dependent voltage source 10I, and then one independent source 80 volt, and 20 ohm and 40 ohm are the two resistors which are connected as shown in the circuit diagram here. See here, we have to find that question asks to find or draw the Thevenin's and Norton's equivalent circuit. Okay. First, we will consider this is the current source. Okay. We will consider the direction of the current I. Also, it has been given this is the I. This is the given I. Okay. Since this is the current drawing here, flowing here, first comes the positive and this is the negative. Similarly, here the positive and this is the negative. Okay. Applying KVL to the circuit, as I start from this end and again I end up with the same end. So first I will write this is the 10I. Applying Kirchhoff voltage law to the circuit. By applying Kirchhoff law voltage to the circuit, first I write this is the point where I select where it reaches the negative. So it is negative to positive means the rise in the voltage. We will consider it as a positive. Again here is positive to negative, it's a fall in the voltage. So we will consider minus 20 and I is the current flowing through it. And again this is my minus 40 into I is the current flowing through it. And I reaches the positive to negative means there is a fall in the voltage. So it is denoted by the negative symbol. 80 is equal to 0. From the Kirchhoff voltage law, we got this circuit, this equation. And this equation, you can write this as minus 50I is equal to 80. We can write this as minus 50I is equal to 80. So that I is equal to minus 80 divided by 50. And the answer is minus 1.6 ampere. We get minus 1.6 ampere. To find E0, we will consider the off of the circuit. We will consider off of the circuit and I will apply the KVL, Kirchhoff voltage law, to the circuit. So, as I said, I start from this point and end at this point. So, 10I minus 20I, 10I minus 20I, again from that plus to minus, so it is minus E0 and loop completes equal to 0. So we can write this as E0 is equal to minus 10 into I. E0 is equal to minus 10 into I. So that minus 10 into minus 1.6 is equal to 16 volt is equal to 16 volt. This is the E0 we got. We got the E0 here as shown in. Now to find the, okay, this is to find E0. Now we will find that R0. To find R0, the current, see that as that dependent voltage source is present here, so that by the concept of what we have till now discussed cannot be applied here. Because we know that to find R0, all the voltage sources should be made short circuit and the current sources should be made open circuit. But it is not given any rule what if happens to the independent source. So that concept cannot be applied here. To find R0, one can be done is we have to find that ISC, the short circuit current we have to find. So that to find R0 it is not possible. So we'll find to find ISC means short circuit the path where the load resistance is to be connected. So the circuit diagram is as shown here with one resistance. This is the point is short circuited. That is B, this is A, the resistance and again the voltage source. Okay, this where the it is going to be connected, the load resistance where we are going to connect load resistance, that point has to be short circuited. So this is 10I and this is 20 ohm, this is 40 ohm and this is 80 volt, and this current is ISC, that is short circuited current. Okay, we will assume that one path of the current, as this is the plus minus, so we will assume this is the direction of the current, and here we will assume the direction of the current. Okay, I call this is the I1 and this is the I2 and this is I. In the question, this 10I, this is dependent source based upon the current at this point. Current at this point. See that seeing this, we can say that I is equal to minus I2 because I is opposing the direction of the current I2. So we'll write this as I is equal to minus of I2. Okay. From the loop 1, seeing here from the loop 1, this is 1, we can write this as 10I. 10I. Okay, this is the plus and the minus, so that minus 20 into I minus 20 into I is equal to 20 into I1 is equal to, okay. See here from the loop 2 we can write that we have got the 80 volt and 40 ohm, so I can easily find out I2 is equal to 80 volt divided by 40 ohm is nothing but 2 ampere. Also I2 is the opposite to the I minus I, so I can write it as I is equal to minus 2 ampere. I is equal to minus 2 ampere. Okay, next we can by from the loop 1 we can write this as I1 is equal to 10I. I1 is equal to 10I divided by 20. I1 is equal to 10I divided by 20. What is I? I is minus 2. I is minus 2 divided by 20. So it becomes minus 20 by 20 such that I1 is equal to minus 1 amps. I1 is equal to minus 1 amps. See the diagram here. By seeing the diagram, we can come to conclusion that this ISC is equal to I1, which is plus I2. ISC, this is the direction of the I1 is same as that the direction of that I2. So I1 plus I2. Because of that, what is I1? I1 is nothing but I1 is minus 1 and I2 is plus 2, so that ISC is equal to 1 amp. ISC is equal to 1 amp. So now we have got ISC and we have got E0, so that we can calculate R0 easily. R0 is equal to E0 divided by ISC, that is 16 divided by 1 amp is nothing but 16 ohm. See, we have found all the components of the network, Norton's theorem and the Thevenin's theorem. We will draw the circuit for that. We will draw the circuit for that. Okay. First, Thevenin circuit. Thevenin circuit consists of voltage source E0 with the value 16 volt and just R0 which is in series with it, that is 16 ohm, and this is the A and B. This is Thevenin circuit. Similarly, Norton circuit. Norton circuit means one current source, that is ISC, which is equal to 1 amps, and one resistance, that is R0, that is equal to R0, that is equal to 16 ohm, and this is A and B. This is Norton's circuit. Okay. As per the given question, we have been asked to find the Thevenin's and Norton's equivalent circuit across the terminals A and B for the circuit shown in figure below. Okay, thank you. We'll meet in some more problems in the next sessions.